from your seniors or what, is very mathematical. You can say it's a mathematical course, right? So if you don't have a very good background in maths, then you find it very difficult and you got problem. Okay, so that's why this your coordinator provided you with all this preparation material, and that is very good. So please go and read it unless you have a very good background already, so you don't need this. But if you don't, this is very, very important. Okay, one of them is function, and that is very important to read because you will, meet this kind of work all the time for your tutorial, right? How to shift the graph, okay, to the right and to the left. Also how to extend your graph and how to contract it, okay. That you need to know, okay, because a lot of graph sketches in this tutorial, okay, even for your exam lah. So that you need to be very good in that. And then there are a lot of complex numbers also, complex function. Okay, it is really very advanced, I can say, the complex function. So you need to read all this before you come to this course. Okay. Now, there is a weekly study guide also, so please go have a look because it is very important for you to prepare. So the weekly, what happened? The weekly study guide. So you can see week 1 today we don't have tutorial. Okay, week 2 you have IRA. I think you know what is IRA. IRA is just a 5-question. Either it is multiple choice or filling the blank. Okay, and you need to finish it by 15 minutes. So all of you must be present. Okay, so today, because there is no tutorial, I say it's hybrid. But next week, start from next week, all of you must be present. And therefore, actually the venue has been changed. That's why today I cannot come in. But you see, it is too late for me to inform you that it has been changed. So the venue has been changed to a bigger one so that it can accommodate all of you. And the new venue is LT22. So please take notes, it's Lecture Theatre 22. Okay, so I will make an announcement again, right, in the NTU Learn. So at this time, because of the pandemic, please bear with me because I cannot promise that there is no more changes. You see, the rule, it keeps changing. I also very confused. So, of course, I understand you also can become very confused after some time because the rule of the government changed, then the university have to follow, and then everything, you see, changed just like that, Okay, so please keep checking your email because I will announce it through the NTU Learn if there is changes. Okay, so I will announce it again that the venue is LT22 later on. So please come next week, all of you, right? Because IRA is a physical test. Then week 3 is IRA number 2. Week 4, there is no IRA because it's Chinese New Year. So some of you get class with it, okay, like my other tutorial, class with this Chinese New Year, so I have to make a makeup. And if I have to make a makeup, then not everybody can attend because your timetable is all different, right? So there is no IRA in week 4. Week 5 is IRA 3. Week 6 is 4. 7 is IRA 5, and so on. And then week 9, there is no IRA again, but you have quiz. Okay, the quiz is 50 minutes. It's a long question and long answer, so it is not multiple choice. Okay, so please bear in mind in that. Okay, and then week 10 also no IRA. Week 11 IRA 7. Week 12 IRA 8, and week 13 of course no IRA. So there are 8 IRA that you need to take, but okay, I will only select the best 6 out of that 8 for your grades. Okay, so please take notes. I do not take all 8 of them. I only select 6, the best 6. So I will knock out those no good one, right? So you can afford to have 2 IRA you don't attend, because bear in mind IRA is you don't have a makeup for it. So if you miss it, that's it lah. Okay, so you can miss at least 2 lah. Right, so that the content. Okay, then here there is mock IRA and the quiz. It is very important for you to do it before you come to the actual IRA. Okay, I am not going to go through this mock quiz or mock IRA anymore, because as you know that the time has been cut. Used to be 2 hours for this tutorial session. Then I have time, of course, to go through the mock IRA before your actual IRA. But now they cut it to 1.5 hours. So I will straight go to ask you to do the actual IRA. Okay, so please do it yourself at home, this mock IRA, and especially the quiz. So do it before you come to the actual quiz. Okay, so let's now look at your lecture notes. Okay, so this is the lecture notes. This is the tutorial. Okay, so please do the tutorial also before you come to the tutorial, because very often people think that, oh, I can just listen. Okay, if I understand, that's all. Okay, but that is not true. Even you can understand when I explain it here. Just assume you can understand when I explain, but that doesn't mean that you can do your tutorial or your exam, right? Because the exam will be always different from the tutorial, even different from the past papers. Okay, you can do all your past papers, but come to the exam, you will find that it is different question altogether. Okay, so if you do not practice, too bad, you cannot do. Okay, that is what mathematics is all about. You need practice, not just to understand one question when I explain to you. Okay, so please be prepared, right? Okay, so now let's go to see the notes. Okay, these notes, he has this preparation to tell you about the rule. So first, this course is very important. So it is my job now to really show to you how important it is. Okay, so I will discuss a little bit on this course, okay, to give you a feel of the course. But it is very important, as you know, that electronic is about signal, right? Nothing else is electronic signal, right? You go to power, it is power signal also that is, sent through the power cable. So it is all about signal. Okay, so you can see how important is this course. It is prerequisite for this communication principle, obviously, because communication is transmission of signal, right, from one destination to other destination. So if you want to take this course in the third year, you need this prerequisite. Okay, I will be teaching this communication principle in the third year. Then the other course is digital signal processing. Okay, so it is also prerequisite. And obviously, this course is also important if you want to take control, although it is not written here as the prerequisite. But control is also controlling the signal, basically, yeah. So it is very important. Now, the weightage, okay, your CA is 40% and it consists about one quiz. I said it is, you will take it in week 9, right? That is 10%. And then your IRA, which is 6 of them, and that constitute 20%. There are 6 IRA, I said, I will take 6 out of 8. Then the 2 labs, I'm not taking the lab. Okay, so I don't know what is this about. But there are 2 labs and that constitute 10%. So altogether 40%, and then your exam is 60%. Okay, and the rule is here. So the IRA is closed book. You cannot open any of your book. Okay, there are 8 of them. It is basically MCQ or fill in the blank. It is 15 minutes. Okay, and there is no makeup, right? So if you miss 2 IRA, it's still okay. All right. Now the quiz is also closed book, 10%, and you need to bring your ID, okay, for this quiz, because during that time I will check one by one your ID. Okay, it is 50 minutes. Okay, and then if you cannot come because you are sick on the day, you need to email me or the coordinator. Okay, doesn't matter, because if you email the coordinator, he will also email me again. Okay, so please email to us, say that you are sick, and you need to provide evidence, of course. You cannot just say that you are sick. So you have to send MC, the doctor MC, to me or to coordinator. Or if you are asked, say, for example, to represent school or university to somewhere, then you need to provide letters from the school or from the university to us. Then I will arrange makeup quiz for you on the other days. Okay, so if you don't send me anything, I will regard it as absence and your mark will be 0. Okay, so that is the so this is just now we have discussed. So this is the book. Okay, and all the relevant formula is given here. Okay, so the first part of the notes is developed or is written by this Professor Tekachan. So if you think that the notes is you cannot understand, you can ask him, but you can also ask me, of course, because I'm here is assisting him. Okay, so if you cannot understand his notes, you can ask me also. Okay, so just to give you a feel now about the course, I will just discuss what is important in this course. I cannot discuss all of them, of course, otherwise we finish the tutorial today, right? So first, a lot of people say that this course is mathematical course, which is true, okay? But you have to bear in mind that you are not mathematicians. You are engineers. We are training you to be engineers, not to be mathematicians. So, if you can just solve problems to get value, even though the method correct, the value you get correct, it doesn't mean that you understand. So that is what I want to say. Okay, you can be a good mathematician, but not a good engineer. A good engineers, you need to know that mathematician is just a tool for us. Okay, a tool to communicate, to analyze. Okay, so basically mathematics to me as an engineer is just a language, okay, a symbolic language so that I can analyze things and I can show it to others, so to communicate with others, so the others will understand what is in my mind, okay, and what is happening. So it is just a symbol, okay? It's just like me speaking English to you so that you can understand my mind, what I am thinking, right? So nothing else. Mathematics is just a tool which we use it as engineers. So please bear in mind when you read his notes, it's full of formulas, but you need to understand what that formula means. Okay, and that is very important. So you need to spend time to think about it, to reflect about what you read. I know that it takes a lot of time, okay? And I know your problems because I've been a student before as well. There are too many things in the university that you need to study, so many subjects. So sometimes you find that you are rushing for times. But it is not just you, it's all of us, okay? Because as an engineer, you need to study what you need to study. There's so many things, okay? In order that you go out to work, then you can do the job. So bear in mind that it is not just you, okay? Everyone, but you need to spend your time, okay, to think about it, to understand what it means. Otherwise, if you are just good in mathematics, I tell you, it is not a good engineer. Okay, so let's just take, for example, so I just want to give you a feel. You see here in his notes, he got this energy type and power type signal. Okay, so let's look, what is the definition of this energy and power signal? Right? Of course, these all are important. I will also discuss a bit later on. So what is the definition of energy and power signal? You see, energy signal is the integration of the amplitude square, right? So you integrate, you get the area under the curve, okay? And then this is the definition of it. He said that a signal xt has finite energy, so the energy must be finite. It cannot be zero, okay? Because if the energy is zero, that is mean there is no signal. That's all. So if you have a signal, then it cannot be zero. But it cannot be also the value go to infinity, because infinity is abstract, okay? It's not real. What do you understand about infinity? It is just abstract. I said that mathematics is just a symbol, okay? So you have to have a finite value, okay? And then power signal, the same definition. You cannot have zero power because that means there is no signal. So the power must be a number, cannot be infinity as well. And that is the equation. I will discuss it later on. So my question here, you see, after you read these notes, so I said that you need to think about it, right? So my question is here is that if you find real signal, right, like my handphone, the digital TV or whatever, it's real signal. So what kind of signal is that? What type? Don't worry, to answer my question, I have to say that why we ask question is depend, if your your component, the CA component is include participation, then of course your answer is important, I will mark it. But as you know, I have already discussed it to you, your components is there already, okay? It is not including what you're discussing here. Okay, so don't worry whether you can answer me or not. We ask you questions so that you can think. Okay, so that is the purpose. It's not whether I get correct answer or not. That is not important because you are here to learn. Okay, so if you are here to learn, my job is just to make you think. Okay, so how to make you think is by posing questions. Correct? Okay, so that is my question now. When you read this already, so what kind of signal we find in the real world? What type? Is it energy or is it power? Anyone? Let me check the online. Mixer. What do you mean by mix? So there is energy and there is power. That is what the online said. They are clever enough, they don't want to answer me, so just say mix. So do you agree? Sorry?
Maybe both,
Sorry?
like both energy and power.
Yeah, that is why I say mix. So he doesn't want to answer basically. Mix, there is no answer, it's just power or energy. But do you agree? Do you agree? Yeah, only him say yes. How about all of you? You, only her. How about you? I said it's wrong. So,
Why?
why? Of course, how you raise her, so that's wrong. Okay, why? No answer also. Okay, let's see. What is energy? To make it fix. Okay, it means that the xt cannot extend from minus infinity to plus infinity, right? If you integrate from minus infinity to plus infinity of this signal, then you get infinite area, correct? So in order that the energy must be fixed, xt is also fixed at certain region, correct? And there is the real signal, because real signal cannot go from minus infinity to plus infinity. Nonsense, right? You start the device at time 0, and you finish it at some time later. It doesn't go to infinity. Is that true? So, the real signal that you find in the world is all energy type signal. Okay? So it is not mixed, it's all energy type signal. Full stop. So now my question is, then why bother to study power? You see, you have to ask questions like this, then it makes your study become interesting. And also then you become to understand more. Okay? So why do you need to study power? What is power? Before that, just let you see the equation first. So that's why I said that you need to understand all these equations. This equation is just symbols. I already mentioned mathematics is just symbolic language. Okay, so it is just symbol give it to you. So you need to understand this symbol. So if you have a fixed energy, say is 2 or 3 or 4, okay, when you integrate this, what do you get in the power? So this integration will be fixed for 2 or what number it is like k, okay? So now k over t, and then you take the limit when t is go to infinity. What do you get? So, yeah, zero. Just say it. Don't worry, I said wrong is wrong. But she is right, right? Zero. Because k over infinity, then you get zero. So it cannot be power type signal. Right? If it is energy signal, it cannot be power type signal. Okay? So please try to understand all these symbols I said. Okay? Otherwise, you are just mathematician. You get zero, so you don't understand what you do. Okay, so you see my point, huh? So now, my question is why we study power? Anyone dare to answer? Okay. Well, I already mentioned again, maths, right? It is just a tool. So power is abstract, basically. It's just a symbol for us to communicate. Okay, so what is the use? What am I communicating? Well, basically, power is a tool for me to be able to compare devices. You see, if you have device A and B, I can compare how good device A and device B using energy, right? Obviously, you want to have device that can produce more energy, right? That is usually is the best device, right? Unless you concerned about other things, but mainly if you want to buy a device, you see that if this device A produce more energy, of course it's better than device B. But how to compare energy? Because energy is depend on how long you switch on. Yeah, I already mentioned. You see the T, the time. How long you switch on this device? The longer you switch on, of course the energy is bigger. All right? Because energy is just power multiplied by time. So it is bigger. But if you want to compare two devices, you must compare it, fairly, right? So you have to compare at certain same time period. So that's why you need to normalize the energy. So when the energy is normalized, energy per second or per time, that become power. Okay, right? So power is just mathematical formula, tools. Okay, it is not real, it is abstract, but it is important so that we can compare devices. So if this device have a larger power, okay, that is mean in 1 second, it produce energy much larger than device B, then of course you will choose device A. Okay, I pose this question because it is important. You go to Sin Tower, you want to buy radio, usually they tell you, oh, it is how many kilowatts the speakers for this radio and this one is how many kilowatts. They are always talking about power, right? They are not talking about energy because they want to communicate with you, right, with symbols. Okay, so that is one thing about energy. Second, I will also like, of course, there are many others, but I will go to part 2, okay, about sampling, right? Okay, so we go to this, but anyway, I don't think I should. How to? Okay. So the part 2 is by Ma Kai Kwang, okay, Professor Ma Kai Kwang. Here he's talking about sampling, and that is very important also, right? So nowadays, you very little devices are analog already, yeah? Mainly digital devices. Okay, as you know now, digital things is so important. The government is keep telling you that you need to digitize everything. Okay, so that's why it's so important to study this. Now your TV is digital TV. You cannot buy analog TV already. Okay, your handphone is digital handphone. So everything is digital. So what is digital, basically? What is sampling? Well, if you want to know what is sampling, I don't know how many of you have taken 2073, the project and design. Anyone? You are going to have it. Okay. So you don't know that, huh? Right. So that's why it's good that I start here. Okay, so you have this analog signal. You will also cover this in 2073. Only one lesson now. Okay, I know that. Right. So you have analog signal like this. Okay, any function. In order that you have this digital TV and so on, that the input cannot be analog, of course, right? And then you need to digitize it first in order that you can input to the TV. So your question is how to digitize this analog signal? Well, very simple actually. You just use key like this, okay? The on-off key, right? On-off key. And there are many on-off key you can buy outside. Of course, now it is not mechanical on-off key. It is not you press and off. Now it is digital on-off key also using a transistor. So you can just send 0, then it means it's off. Okay, it is not connected if 0. Then if you send 1, then it is connected. Okay. So of course the result will be something like this, right? So when the key is on, you get a pulse coming out. Then when the key is off, you got nothing, and then pulse coming out again, nothing, pulse coming out again, nothing, and so on. So you basically just get this value, okay, the dot there, right? So the question for this course that you want to learn is that how fast should I sample? Okay, that is very important. And as an engineer, actually, your job is not just to know how fast, but also to balance between cost and quality. Okay, I will discuss that later on. So if you sample too slow, something like this, so you just sample here and then later on there, then you cannot recover the signal back at the output, right? Because what you get, you just link this value and that value. So what you get is just a straight line. Okay, so your signal is become distorted, right? Because you lost this peak back. Okay, so you need to sample more, and that is the question: how fast? Okay, obviously you tell me, well, as fast as possible. No, that's why you see, an engineer, you don't just talk about how fast, but you're also talking about cost. If you sample too many, then you need to store all this value, right? Okay, and where do you store? Of course, in memory, and it costs money to buy memory nowadays, especially if the capacity is very large. Okay, so it is about money, especially if this is a consumer product, which billion people is going to use it. Then you can tell me how much money is that. You see, so all this engineer's job. Okay, you need to balance it. So that's why we need to study what is the good numbers of the sample. So that is what you need to study. Okay, so what is the minimum? The minimum is mathematical problems, right? So Nyquist already come up with a theorem to get the minimum. But obviously minimum is not enough. So as an engineer, you need to give a margin, we call it, okay? Right? Because minimum is very bad, right? So that is one of the things you need to study. But look at this, you will come across in this course, mainly you sample along the time axis. Okay, so we call it the time domain, right? Or the time dimension, right? So that is what you always come across in 2073. Here, we sample along the time. But very often, because it sticks to your mind, you see, I have been student before, so I understand after I learned this, it just stick to my mind, sampling must be always in time. But that is not true. That's why I said to you, it is just mathematical formula, it is just a tool. So can you give an example when I sample not in time? You actually look at it already. You look at it so many times in this screen. They don't sample in time. So what do? Well, Okay, it's a bit difficult to switch your mind, right? I agree. But look at pictures like this. Pictures are stationary, but you need to digitize this. I already said your TV is digital TV, you know. So what do you have when you digitize a stationary picture? It's not in time, but what do you call it? What do you get if you digitize stationary picture?
Pixel.
Sorry?
Pixel.
Pixel. Is that what you say? Huh?
Right.
Yeah. So pixel, okay? You got a lot of pixel to represent the pictures. So you can understand, huh? If the pixel is not enough, not many, then you get bad resolution. That's all. Right. So if you want to get a good resolution, the pixel must be many. But if you have too many pixels, then you can see that your memory must be what gigabytes, whatever, right? So you get a very expensive handphone because of the pixels. Okay, so you understand that now, huh? Okay. Now, okay, the other things that we want to talk is about Fourier series and Fourier transform. How many of you have taken second year maths? Yes, you have. So you know about Fourier series, Fourier transform, right? Anyone else? No? Okay. Okay, I'll just give you a feel of it. So what is Fourier series and Fourier transform? Okay, all these are maths, as you see here, a lot of maths. But you see here, okay, first, before you go and see this picture, I want to ask, can I say signal is a vector? Yes, yeah, of course, because I say so. So, but why?
Direction.
Sorry?
Direction.
Uh-huh. Only direction.
The direction
And magnitude.
Yeah.
That is the definition of vectors. So anything that have direction and magnitude, that is a vector. So signal, obviously, you know where the signal flow and what is the amplitude of the signal. Right, so signal is a vector. So, of course, you have learned vectors in the A level or poly, some of you, right? So you know that any vectors V, you can decompose into components, right? For vectors is either J and I. Of course, if 3 dimension, you got K, but it is a bit difficult to draw, so I don't bother to draw it. Okay, but the question is, why only 3 dimension? Not necessary. Right? If I put the time dimension, then become 4 dimensions. So mathematically, the dimension can go into infinity. That's what I say again, mathematics, it is just a symbol. The dimension can go infinity. It's not necessarily must be 3 or 4. Okay? Right, but if you want to draw, you can only draw 3 lines. I don't think you can draw 4 anyway. Okay, so there is vectors. So vectors consist of components. Okay, so the same as signal, because signal is vectors. So if you have a signal ft like this, you can also decompose it. Okay, so those who come already study the maths, second year maths, know that this is Fourier series. Okay, so NEFT can be decomposed into not the I and j as vectors, of course. It is cosine and sine. So the components of FT, any FT, it is consisting of a cosine and sine function. That's why it's so important to study sine and cosine, because there is a component of signals, right? And they goes to infinity, from 1 until infinity. So the dimension is infinite. It's not just 3 or 4. Okay, and this is very important. Okay, just now I show you the drawing, right? So you see this signal, the original signal, it consists of many cosine and sine. But here, Ma Pai Kwang only sketched 2 of them, because if too many, you cannot see anyway. Okay, so he only draw the blue one here and the red one here. So if you add these 2, you will get the black one. But of course, only 2, you don't get exactly the same as the black one, because the black one consists of many. Okay, so this is important, right, to study this. Because why? Well, it is many applications. The first application is speech reconstruction, that is one. And then the second is speech recognition. Okay? I'll tell you why. Well, if I say A and she say A, cannot be the same, right? Our accent in the first place is not the same. Okay? So, if you study the way I say A, then you know how many cosine is consisting of it, and then how many sine, right? So you can reconstruct my speech if you know. And then you also can reconstruct her speech. You see, and then not only that, you can manipulate and change the way of my A if you just delete certain cosine or add certain cosine or sine, right? And then it can become like her. So you see, I can fake, okay, I can fake the voice of someone, but please, I don't teach you how to fake things, okay? But if you want to do it, you can, right? If you know the components, okay? And that is important. So, my question is, how do I delete certain cosine or certain sine from the function, the signal? How do I delete it in electronic devices? What did you use? Don't know also. I think you have come across it. Have you studied circuit analysis? Yes. So, what did you come across? How can you delete? So,
Filter.
Filter. What is it?
Filter.
Phasor?
Filter. PGSO.
How to pronounce? How to spell?
PGSO. Filter.
Phasor. No. Filter. You just filter the signal, right? Like you filter the water. If you want to get it of, the things inside the water, right? You filter it. So the same as this, you use filter. You know filter, right? So I can filter any function that I want. Okay? So that's why the study of this very important, right? Okay, so you should know that in this Fourier series and Fourier transform, right? Now, my question again is that you told me that you already study circuit theory or circuit analysis, right? What do you study that is similar as Fourier transform? Here you will study Fourier transform, right? Which is this. Yeah, it's the Fourier transform. See, that's why you need to study vectors, right? And signal here. So you can see they are similar. Now, where is the Fourier transform? This is sampling, okay? I already mentioned it. Now the Fourier transform, okay? So all right, the formula for Fourier transform. So in circuit analysis, what is very similar to this? What did you study there?
No.
Who said?
No.
Okay. He's always answering my question. Okay, the rest, where is it? Good. You are right. Laplace transform, right? You learned that, huh? So now my question again is here. You see, everything you learn, you need to ask questions. Why should I learn? If I already learned something else, right? It's good to ask questions. Huh? Okay, I don't want, I'm not teaching you to be like this. Okay, but it is, you need to think, right? So why is it that you need to study Fourier series or Fourier transform? Okay, Fourier series is just for periodic signal, right? The transform is for non-periodic. So why you need to study Fourier transform again if you already study Laplace transform? What is the difference? Can you see the formula? What is the difference? Let's see what the people. So, what is the difference online? Can't you see? Nobody answer.
Not sure.
You already learned and then you can answer. Huh? What is the difference in this formula?
Not is e to power minus st. For Laplace is e to power minus st.
Okay, that S is still time. Okay, it's just different plate. All right. So that is not the difference. Okay, they just use different plate, but it's still time. Almost forgot to say something about time. But before that, can you see what is the difference? Do you see this? I cannot. Here doesn't have it. You see my arrow here? What is the difference in the integration limit between Laplace and Fourier? Interesting, you forget everything when you...
Laplace is from 0 to infinity.
Yeah. Okay. So Laplace is from 0 to infinity. Fourier is from minus infinity to infinity. So what does that mean? That's again, I'm going to pose you all these questions. You look at the mathematical symbols, but if you don't bother to think, then you don't know what is the difference, right? So what does this mean? What is the difference between Laplace and Fourier? Look, this limit is time limit, nah? Okay, because you integrate along time axis. So for Fourier, it means that the signal happens at minus infinity. What does that mean? It means that eternally pass. You don't know when the signal starts, okay? Somewhere in infinity. And then the signal will go on until don't know when. Okay, so there is Fourier transform. But Laplace, you know when it starts at 0. So you switch on the device, that is when it starts 0. Okay, so what does that mean? Sorry?
You can control it from 0.
Just control, but it means something. Okay, it means that Fourier transform is to analyze the signal when it is already stable. Okay, so it will go on like that forever. It's stable signal. Okay, but Fourier for Laplace, you started at 0, so the signal is not stable yet. So what do you call that in your circuit analysis? They call it some name, right? What is that? Transient response. Okay, so that is what you want to study. Yeah? So if you input a step function to a device, the Fourier is, you see, it is the response when it is already stable. But Laplace transform is start at 0. So it start increasing, and then you want to study how this signal will go to stable condition, right? So it can just goes on oscillating. Then you say it is not stable. So that is how you analyze it using Laplace, not Fourier. You cannot. Okay, Fourier is to study the signal when it's already go to stable. Okay, and how we change it. Right, so that is one thing. Now, just now I said, I nearly forget. Right, you see, this is always in time. Okay, right? But it's not necessarily must be always time. I said time is just a symbol again in mathematics. So Fourier transform is just a mathematical tool, right? So before I go to non-time yet, so this is just a mathematical tool. What is the purpose of this mathematical tool? Is to simplify your analysis. That is what mathematics is for, right? So if you find that your equation in time, okay, the equation in time, is very difficult to solve, For example, if it is consisting of sine and cosine, very hard to solve it. Okay, when you multiply it and you divide and so on, how to solve this sine and cosine equation. So to make it easy is to take the Fourier transform. So imagine I'll give you an easier example. So if you are in the secondary school, right, you find the equation consists of multiplication, division, so many, very difficult to solve. How to simplify this in secondary school? Secondary school, I'm not asking you any university things, you know. So you should be able to answer me. How you simplify it? Secondary school, right? How you simplify, you know, got a lot of multiplication, division, then you want to simplify, how you do it? You take what? Huh? Yes. It's answering, but no, nothing here, something. Yes. Surprising. You take the what? The log, right? So that the multiplication become addition, the division become subtraction. So that is how you simplify. You take the log. You will also come to do here in the university, right? Things very difficult, you take the log, then become addition and subtraction. And in the past, now you take the log very easy because your calculator the log. But in my day, I need a table. Okay, so the same way as this Fourier transform. So if your equation in time very difficult, you want to make it simple, you take the Fourier transform and you use the table to solve it. Okay, give an example. If the time domain equation is convolution, you will learn convolution later. Okay, and then it's very tough to solve it. So how to make it simple? You take the Fourier transform and it becomes what? Multiplication. Okay, so that is just an example. So from something very difficult, convolution which consists of integration, you know, integrate this, integrate that. Then you take the Fourier transform, you just multiply the thing. Okay, and you use the table to solve it. So that is how the Fourier transform is formed. Okay, but I said that it is not necessary must be in time. Bear in mind, Fourier transform is actually a reverse of the original signal. Right? The original signal is in the time domain. You take the Fourier transform, is frequency domain. So frequency is just a reverse of time. Right? As you know, f is equal to 1 over p. So you just reverse it basically. Right? You reverse the equation, then it becomes easy. Okay, you use the table to solve it. Now, but there is time. Can you give example something that is not time? I think that's not already said. Well, if you study image processing, that is what I said just now. You got a picture, it is stationary in time. You also need the Fourier transform to solve. Right, when the equation is now is not in time, of course, because picture is pixel, right? So you get the whole equation in distance, basically, right? So distance between pixel is distance. So if you want to solve it, you also use the Fourier transform, but it is not in time now. If you reverse the distance, become 1 over distance. okay, and solve it. So not necessarily must be time. If you, in the final year, there is a subject, I believe, right? It is in image processing. So you come there, don't confuse yourself, because sometimes you need to switch your brain. After you get used with all this, sometimes very hard to switch it away. So please just take notes on that. Okay, so that's all. I hope that you understand what all this means. So when you study, you can, think about it. Okay, any question before we leave? No? Well, you seem to understand everything, is it? Okay, Life Plus can deal with function that, oh, no. They are different now, of course, but that is not what I intend to. Okay. Any more question online? No question from you? Then that's all for today. Okay, so please remember next week all of you must turn up. Okay, online, that's all. We finish here.
Thank you, Prof.
Okay, see you next week.
Thank you, Prof. Bye.
Okay, so I stop recording, stop sharing, and goodbye.